create a video for chapter 5 notes, part 1. So I'm going to share my PowerPoint here. Nope, it's not letting me do that. So we need to convert it into a newer form. Share this. So we briefly talked about this in class, but I want to go over chapter 5 notes, part 1. All right. So we talked about how the skeleton has 206 bones, and the key piece there is that we're talking about the adult skeleton because the fetal skeleton has more bones because of pieces of the spine that are not fused together. And then we have two major divisions. We have the axial skeleton and the appendicular skeleton. Axial skeleton is our head and our vertebrae and our rib cage, and then our appendicular skeleton are our limbs, or our arms and our legs, and our two girdles, which consists of our shoulder or our pectoral girdle and our pelvis. We talked about 5 vital functions of the skeletal system. The first one being support. So our bones are what give us our frame. They're also going to provide an attachment point for skeletal muscles to attach to, which is going to help move our frame. Protection, it's going to be protecting, providing protection for our brain, for our heart, our lungs, for our reproductive organs. Also storage. We have 2 different types of marrow. We have red marrow and we have yellow marrow. Red marrow is blood and yellow marrow is fat, and those are both stored in bone. And then finally, there's the process of hematopoiesis, or blood cell formation, that's going to be happening in the red marrow. And that is all types of blood cells. Red blood cells, white blood cells, and platelets are going to be created in the bone marrow. So we have 2 main types of bone. We have compact bone and we have spongy bone. They're both hard. Compact bone is just going to be organized in a compact manner. And then spongy bone is going to be more in kind of a lattice or like a chain link fence type organization. We call the structural organization of compact bone osteons, and we call the organization of spongy bone trabeculae. Inside of spongy bone, inside the spaces in the kind of lattice structure, that's where marrow is going to be found. Then we have 4 shapes of bone: long, like the femur; short, like the carpals or the bones of our wrist; flat, that would be like our skull bones and our ribs; and then irregular, and that would be something like a vertebrae. And I can grab some bones out. So this would be part of the pelvis. That would be considered an irregular bone. This is looking at a rib. All right, I would consider that kind of a flat bone. This is a tibia. This would be a long bone. Here's a hand, right? So we have carpals, that would be short bones, but these metacarpals would be long bones because they're longer than they are wide. Okay. So looking at the left side of the screen here, that would be a compact bone, and it's arranged in circular units that are called osteons. I'm going to make sure you can see my laser pointer. So this is an osteon. And then over here, this is spongy bone. So this is the actual spongy bone. And then the spaces in between, the lattice-like conformation, which is called trabeculae, is going to be filled with our red and yellow marrow. So the red stuff, or the kind of dark pink stuff you see here, would be red marrow. And then these white globs, if you will, are going to be yellow marrow or fat. And those are 4 different shapes: long, that's saying flat, short, and irregular. Looking at the structure of a long bone. So we are going to look at the subanatomical features of a long bone. And so we have some terms here. We have the shaft part of a long bone, which is called the diaphysis. We have two ends, and these are called epiphysis, or epiphyses would be plural. If we're looking at bone, okay, there is going to be, all of our long bones are going to be found in our limbs. And so when we talk about our limbs, we can talk about a proximal epiphysis and a distal epiphysis. So proximal is going to be closer to the point of attachment. Distal is going to be further away. This is going to be important. There's going to be a rubric where you're going to have to be diagnosing fractures. So proximal and distal epiphyses. Then we have articular cartilage. Articular cartilage is going to be covering the ends, or the epiphyseal ends, of long bones. So this bone has to articulate or meet with another bone. And if we had bone on bone, it would be crunchy and it would probably actually fuse together. So what covers the ends of the long bones is something called articular cartilage. That articular cartilage creates a nice smooth surface so that bones can freely move against each other. We're going to have a joint there as well. If that articular cartilage breaks down, we have breakdown, inflammation at that site, and we have, you guessed it, arthritis. Okay, I'm going to go back for a second because I missed one. The periosteum is a connective tissue sheath that covers the outside of the bone. Okay, a bone is an organ, so it's two or more tissue types coming together. And so there's bone on the inside, or bone tissue, or osseous tissue. We have connective tissue around here on the outside. Epiphyseal plate will be seen at the ends, basically at the metaphysis, which is the kind of joining between the diaphysis and the epiphysis. That is going to show growth, so longitudinal growth. And the epiphyseal line is when the epiphyseal plate, which was at one time cartilage, is going to be completely replaced. And so there'll be a line there to say, hey, this used to be here, but it's completely been ossified or gone through the process of ossification. Just like my bone here. Okay. So again, shaft, diaphysis. Two ends, epiphyses. Epiphysis is singular, epiphyses plural. Okay. Periosteum, connective tissue sheath covering the outside of bone, except for the very ends, is articular cartilage. Articular cartilage allows for smooth movement. Okay. We then have the epiphyseal plates on either end. If you're fully grown, you can see epiphyseal lines. And just for point, the majority of the shaft is going to be compact bone, with the epiphyses being spongy bone. There is some spongy bone in the middle of a bone, all right, which is there's a medullary cavity inside of the bone. The medulla means the inside. So there's a medullary cavity on the inside. There is some spongy bone in there, but predominantly the shaft is going to be compact bone. The ends are going to be made out of spongy bone. And we've talked about yellow marrow and red marrow. Yellow marrow is fat, our adipose tissue, and red marrow is the site of hematopoiesis, where all of our red, white, and red and white blood cells, as well as platelets, are going to be made. On every bone, there are some different markings, okay? And so when you get further into anatomy, you can actually, look at the different markings of these bones, fossas, crests, depressions, but that'll be for college anatomy, not for Miss Giro's anatomy. So this is zooming into marrow. And so this would be our red marrow. And then you can see the yellow marrow, which is the white globulates of fat here. These are a combination of red blood cells, of white blood cells. This right here, this gigantic cell, is probably a megakaryocyte, which is going to pinch off and become a bunch of platelets. So this is red marrow, even though it looks kind of purple. And then this is yellow marrow, even though it looks kind of white. So again, hematopoiesis of all of our different types of cells are going to happen in our red bone marrow. And so this is showing the red blood cells. These are our 5 different types of white blood cells, and then our platelets are all going to be created in bone marrow. So that was kind of the macroscopic anatomy, or what you can see, besides marrow, obviously, because you need to look at that under the microscope. We are now going to talk about the microscopic anatomy of bones, specifically of compact bone. And so compact bone is arranged. Oh, let me get my little thing so you can see it. So again, cross section of a bone here. All right. Bone is going to be arranged, typically compact bone, in a series of osteons. All right. And it's a combination of living cells or osteocytes that are going to be um, surrounded by inorganic calcium deposits that are going to give bone its hardness. Okay. And then there are different types of protein fibers like collagen that are going to help give bone their strength and rigidity. So we're going to be looking at the microscopic aspect of bone when it comes to osteons, which hopefully you can see right here. Okay. So when it comes to an osteon, all right, there are mature bone cells spread around that are called osteocytes. And basically, they live around a town center that's called the Haversian Canal. Inside the Haversian Canal, so that would be here, there's going to be a central blood supply. And then all the people, the osteocytes, are going to be arranged on little streets that are called lamellae. Let's call them lamellae lane. They live in little houses on these lanes that are called lacunae, like cocoons. And then they also are going to be connected by telephone wires to each other, the little osteocytes that are called canaliculi. Additionally, neighboring osteons, so this is an osteon, and this is an osteon, and this is an osteon, and this is an osteon, they need to be able to communicate with each other. So there are tunnels in between, or canals, and we call those Volkmann or perforating canals that exist at right angles. So what the heck does this look like? So here's a cross section of bone here. Okay, so this would be the diaphysis, and I told you in the medullary cavity we've got a little bit of spongy bone, so that's why that looks different in here. This is an osteon. This is an osteon, and this is an osteon, and this is an osteon. So where we see the central blood supply is the Haversian or central canal. The osteocytes that kind of look like ticks or fleas here, those are the mature bone cells, and they are going to be arranged in concentric rings, all right, around the Haversian canal or the town center in rows or rings that are called lamellae. So I think of lamellae lane. They live in little houses that are called lacunae. Basically, they're spaces. But then each of the osteocytes are kind of separated from each other, but they're able to communicate with these cytoplasmic extensions that are called canaliculi, canaliculus to be singular. But this osteon needs to be able to communicate with this osteon. And so that's why we have, this would be a perforating or Volkmann canal. So like you see these two osteons, they need to have their blood supplies connected. So they are going to be connected with a Volkmann, or it's also called a perforating canal. Just showing another picture, okay? So here is the compact bone. Out here, organized in osteons. This would be towards the medullary cavity, the inside of the bone. This is trabeculae. This is showing one of these right here. So it's an osteon. And the fibers of the lamellae are actually going to run in opposite directions. So they're going to run this way, and then this way, and then this way. And I think I may have talked about it in one or both classes, but having the fibers go in opposite directions for every lamellae ring is going to help increase the strength of bone, so that they're all in one direction and you just have to twist it in the right way. You could very easily twist and break that bone, but it's going to overcome those type of torsional forces. This is a zoom in. So this, the white here would be the lacunae. And that is where the osteocyte is going to live. And then this is the canaliculi that are going to stretch out and extend to be able to communicate with different cells. Again, looking at the cross section here, trabeculae more towards the inside is a spongy bone, compact bone arranged in osteons. This is going to be the periosteum out here. That is connective tissue sheath that's going to cover the outside of bone, again, except for the epiphyseal ends. This is exactly what we have right here. So this is an osteon and this is an osteon, okay? There's a central canal. That's where the blood supply is going to be. These are the rings, the lamellae lane that are organized around kind of the town center or the center blood supply. These are the osteocytes or the mature bone cells that live in little rooms that are called lacunae. And then you can see these cytoplasmic extensions and they are called canaliculi. What you cannot see in this photo is going to be the perforating or Voltzmann's canals like here that are going to communicate from osteon to from osteon here to osteon. All right, so bone formation. So we talked about that cartilage is the building block for bone. Okay, and the process of making bone is called ossification. And that's going to happen really at 2 times in your life. So when you were a fetus, right, all of your bones started off as cartilaginous templates, if you will, and then they went through the process of ossification to become bone. If you were to ever break a bone, bone would be kind of filled in as cartilage, and then that cartilage would then slowly over time be replaced by bone. Okay. So this would be kind of during fetal development, all of your little bones started off as cartilage. And then they developed what was called a primary ossification center. And then there are secondary ossification centers here, as you can see, where that template, that cartilage is getting replaced as bone. And then if we look at a mature bone here, we're left with the epiphyseal plate or the growth plate, as well as the cartilage at the end here, all right, which is the articular cartilage, which is going to provide that nice, smooth, frictionless surface. All right, that is it. All right, that is it for chapter 1 notes, part 1.